Hi, everyone. Thank you for coming to our talk on securing front-end attack surfaces. My name is Liran. I'm a developer advocate at Snyk, and I'm on a mission to help developers build applications securely using open source.
My name's Eric Graham. I'm a senior product line director with Akamai, and I'm part of the team that figures out how do we protect all the web-facing workloads from the threats that are out there on the web every day. Today, we're going to talk a little bit about a new partnership between Snyk and Akamai that empowers developers and web protectors with a complete view of all the vulnerabilities that are present in their front ends across all permutations of real user experiences. And in this talk, we're going to particularly emphasize what do we mean there, all permutations of real user experiences. So what we're covering, first, just why talk about this now? Why are we looking at the front end and the attack surface that it represents? Do vulnerabilities really exist out there in the modern front-end frameworks? How, as a front-end developer, can you do front-end security? How do you understand what that attack surface actually is? And then how do you get visibility across all permutations of that attack surface?
Let's talk about security in front-end frameworks and gain a better understanding about the attack surface. XSS has been a long-time concern for web developers, as old as the invention of browsers. And today, it poses as much real threats as it did 30 years ago. We're witnessing the impact of supply chain security risk to the attack surface, from dependencies that you add to your project to third-party scripts which are beyond your control. In fact, XSS has been on OWASP Top 10 since its first debut in 2003, and is still #1 in the latest edition of OWASP Top 10 Web Weaknesses. This is further supported by data from Snyk State of Open Source Security 2020, which shows XSS coming on top as the most prominent security vulnerability across all open source ecosystems. So no wonder that if there is something every developer remembers about front-end security, it is data sanitization and output encoding. Web developers often associate front-end security with XSS because it has been such a dramatically dominating security concern for them for such a long time. So fast forward to the current decade of JavaScript renaissance, we have modern front-end frameworks like Vue.js, Angular, and React, which champion for security on and by default. And the importance of security for these projects clearly stands out in the project's website in the form of security guidelines. So let's quickly see how frameworks approach security by default. Starting off with Angular, for example, it defines the following template, which, using an interpolation as a syntax, it is secure by default. So anything going into those curly braces is actually going to be output encoded in the right context on the browser as it renders things out. Angular even have this inner HTML that lets you push raw HTML into the DOM, but it protects you, yay, with a built-in DOM sanitizer service. As another example, React introduced JS6 to allow you to build web components with JavaScript. And when you use React, it automatically performs output encoding of all that HTML content that gets safely inserted into the DOM. Another yay. So this looks all good and great, except there's always that edge case as a developer that all of this output encoding and sanitization just gets in the way for me. Maybe, for example, I need to push a base64 encoded image data source into an HTML tag, and then it usually gets sanitized completely out of what I wanted to enter or just typed in as plain text because it's output encoded. So to allow this flexibility, all of these frameworks include escape hatches, yay, to allow developers to just do it. So for example, Vue.js has the vHTML binding, which allows developers to put HTML tags into the DOM without any output encoding or sanitization that takes place. Please do not do this at home. At least the documentation is very clear about this behavior. Watch out. This is a good time to remember that we're consumers and citizens of open source software. In this regard, our mental image of the applications we build is often inaccurate. While we think we've built all of this app, in reality, the code we wrote for this application is significantly small. And actually, open source dependencies account for roughly 90% of the application source code. Unfortunately, the problem gets even more complicated than just security issues in your dependencies. Based on security research shared in Snyk State of Open Source Security Report, over 70% of vulnerabilities discovered in Node, Java, and Ruby are found in indirect dependencies. Indirect dependencies are those that we have less control of and mostly unaware of at all in our projects. This brings us to face the reality for what it is. Web applications are rarely built on top of the core framework code alone. And so, to fill their gaps, developers end up installing dependencies for these frameworks. So, the question I ask, do front-end security vulnerabilities exist in these days of modern front-end frameworks? This is where vulnerabilities sneak in, and I want to walk you through it quickly. We're going to use Vue.js to build a security bingo web app. For this project, I'm going to install 3 dependencies: Vue itself, a confetti animation library, which granted every project needs, and Vuetify, which is my UI components library, so I don't need to write any CSS from scratch. Looks like no security issues either, so that's a good thing, I think. Here is our web app. For people to share the results, I created this component that you can tweak your message and post it on Twitter to share with your friends, obviously. And as a good developer, I added validation for the text, which, it helps with the UX to show what a user typed in. So it shows all of that in an error message if something bad happens, like, going through over 280 tweets or something like that. So all of that is supported within Vuetify as a UI library. So I do not need to install any other components either. So that's a good thing. Since this is a security talk and we're at a security conference, I am going to try my luck at injecting a script with a classic alert function. Look at that. Apparently, there's an XSS in Vuetify. But I thought we did not find anything because NPM reported 0 vulnerabilities. So did we right now discover a new vulnerability in Vuetify? Honestly, it's probably very rare to see 0 security issues in the JavaScript ecosystem, if you know what I mean. So let's see what happens when I try to deploy this web app to production. My Snyk plugin on Netlify actually failed the build. Why did that happen? I'm going to drill in at the logs, look a bit closer, scroll down, and see what's going on. Apparently, looks like Snyk found an XSS vulnerability in Vuetify. That UI components library, which we were hoping to be safe, and now we're at least not deploying that to production. So what led to this happening as an XSS in the Vuetify library itself, if you ask? If we open the commit that fixes the security vulnerability, we can see it's a classic output encoding problem, as it's always been with XSS on the browser. The thing is, this XSS vulnerability in Vuetify has been there publicly known since 2019, for a long time. Don't mistake this Vue.js vulnerability to be a one-off and only for Vue.js. Other ecosystems have exactly the same issues, and the fact that you might be a developer following secure coding conventions doesn't mean other developers are doing the same. Here's an example from the React ecosystem. We have Markdown to JS6, a React library spanning over 2 million downloads a week, showing 2 high XSS vulnerabilities, one of which is as recent as May 2020. Go check your app. So at this point, we can make 2 observations about front-end framework security. 1, frameworks today provide good security by default, but you should still be vigilant about security issues in the dependencies you pull into your project overall. Secondly, Snyk provides great value due to its security research and vulnerability intelligence that uncovers vulnerabilities that other tools miss out. So let's review some security tooling that is available and closer to your workflows as a front-end web developer. One of which is Lighthouse. If you're a front-end web developer, Lighthouse is probably needing no introduction from me. It is available right there in Google Chrome when you power up the DevTools. Yet, perhaps an often missed part about Lighthouse is that it features a security report for vulnerabilities and vulnerable JavaScript libraries specifically that it detected on the page. Lighthouse has a rich ecosystem of CI integrations and CLI tools that you can easily embed in your workflows and make sure you test for best practices, such as vulnerable JS libraries. Another tool that is well known around front-end developers and the web performance community is WebPageTest. Yay! It's a free tool and open source project that provides performance insights and often used as an ad hoc and automated CI checks to ensure websites are kept in shape. Let's test the Akamai developer website. So I'll just type it in and use the default locations and browser and fire the test away. In the test result page, I can now see the top level scores for this website. And notice how I only get a B score in security compared to A score on some of the other performance metrics. So let's dig and click in. Why does this happen? Why did I get a low security score? Here I can see what's going on. On the left pane, I see that this page includes a vulnerable version of jQuery. And on the right pane, I see that some security headers as an example of a good practice, but they're missing other security headers that will be really helpful to increase the security of this website as well, like content security policy, hence the total B score. So we talked a lot about being mindful about the dependencies in my projects, and then we showed how you can detect vulnerable JS libraries, even security headers, as an end-to-end test. But even that doesn't cover the entire attack surface on the front end. And with that, I'll hand it over to Eric.
Thanks, Liran. When we're talking about attack surface, the first thing that I do is go and look at how many places are we sourcing content from. That's a pretty good check of just how broad is this attack surface going to be. As we look at developer.akamai.com, we can go to domains and web page test, and we can see that there's 49 domains that make up this website. Really, 49 domains for this page right in front of you, just this single page. So how is that possible? This is where we really want to delve in and explore the attack surface. And our friend Simon has contributed a great tool to the community, and you can get to it through webpagetest.org. It's called Request Map. It's the rightmost link here that we're pointing at. And when you hit Request Map, it's going to show you what I like to call the fireworks. This view is showing where each little dot is a different asset or a different domain that is being contacted. And it's shocking, right? You look at this simple, relatively straightforward site on the left, and there are 49 different domains that are being contacted. And that's a very simple measure of the attack surface. But typically when I sit with application teams and I sit with web protectors, and they see this for the first time, their application that they put together out there rendering in a browser, they're really shocked by what they see. So let's simplify this a little bit. Let's examine what all is in those 49 domains. As Liran said a moment ago, there's your code and there's other people's code. So let's go back to this great picture. When we look at the app, this is absolutely true. But if we zoom out and we look at the user experience as it's actually rendered in our end user's browser, we're going to need a little more space to talk about this. First, there's widgets that we include, like that privacy compliance widget, that bar across the bottom of the site. Typically, there's some kind of A/B testing service, which this is great. It lets people that aren't developers put code on the site so that they can experiment. Then we get some widgets like click to chat. What modern commerce site or customer experience doesn't have the ability to click to chat? And frequently there's the personalization providers. People that like green hats versus no hats get different experiences, as an example. And then there is the ever-present black box of the tag manager, whose sole job is to include other JavaScript, other tags, and do so in a very convenient and easy to use fashion, and make sure that we wrap those with the right conditional logic so that we fire the right one at the right time. And examples of what's in there: analytics, pretty straightforward. We all want to know how this experience is being consumed. But there's all the marketing tech that goes with it. And marketing really leads to social, so we have all of our social tracking, which then leads to all the advertising technology, and on and on. You can keep going down the rabbit hole. But we load up these experiences with so much technology to make it possible for the business to understand what's going on, optimize what's going on, efficiently and responsibly manage compliance burdens, interact with the user, that what ends up happening is by the time a real user is loading the experience, it's not just a question of your code and your dependencies. It's your code, your dependencies, and all of the services that are included in your front end. But wait, there's more. Each one of these things, once you include them, they in turn have the ability to include somebody else. And they have their own dependencies and their own resources that they draw in. And this is the modern supply chain. And this is where it starts to get really crazy. You can spend a lot of time in request map digging into this in detail for a particular page view. But let's simplify this back out. Here is our simplified user experience. I think it looks like an octopus. You'll hear me talk about this as the octopus. It sprawls all over the place. It's got long tentacles. It grabs things. It sticks to things. It goes in lots of directions. But this is representative of a very overly simplified user experience that we're putting out in our web front ends that real users come in contact with all of the time. So 49 domains, how is that possible? Well, it's quite probable, actually. It's just what a typical user experience looks like once you load it up with that ecosystem of services and widgets that we all rely on for the rich, modern, personalized, interactive web experiences we're all used to. But as a web protector, as an application developer trying to preserve the integrity of your experience and ensure you're shipping secure experiences, it's like arm wrestling an octopus. You just can't get a hand up. This front-end attack surface that all of this represents, it's big. It's really, really big. And it's growing all the time. It's a collaborative creation, so it's not just that it's your code and the dependencies that you chose to include. It's your code, the dependencies you chose to include, the services and third parties and assets that you use from elsewhere, and in turn, the services and third parties and assets that each of those use, and so forth and so forth. So this ends up being a really big picture pretty fast. And across that big, complex picture, all of this can change. And it does change, and it changes fairly frequently, and it does so unpredictably. When's the last time one of your social partners or ad tech partners or a widget provider called you and said, hey, we're about to commit a change, just so you know? That's not how this works. You link out to their asset, and they update their asset on their timeline as they see fit, and you are trusting that they are responsibly preserving the integrity of your experience as they do so. And as if this wasn't hard enough, this whole front-end experience is personalized, which means the attack surface is personalized. I may get the A case, Liran may get the B case. I may get the receding hairline segment, he may get the awesome hat segment. The experiences are built to tailor to the users that are interacting with them, but that means the attack surface that's presented to each user also gets tailored. So it's not that we have one version of the attack surface we need to understand, it's that there's many permutations of it out there. And, I want to share a quick and very simple story about this. I'm using Akamai's developer site as an example, but this actually came from a real customer, and it was early in our journey of rolling out to address this front-end attack surface. They had run a big project. They did all the things that you would do as a responsible application development team and said, this week, we're going to get all the old and vulnerable library versions out of our application. And they did that. They cleaned up everything. They got all their dependencies in order, and they got all of the known vulnerabilities out. They used tools like Snyk to look in their project dependencies. They ran lighthouse testing. They even went out to web page test, and it all looked great. A big improvement in their security posture. And then they logged into Akamai's control center, and page integrity told them they still had a problem. In fact, we told them that there was still an ancient version of jQuery out there and that it was a pretty big problem. And their response was, Akamai, your tool's clearly broken. When we look at everything else, when we look across our pipeline, when we look in our code repo, when we load this in individual user sessions, we cannot find this thing that you say is there. Are you sure your technology is working right? And it was. What ended up happening is their widget provider for that cookie compliance banner at the bottom, it loaded, and vast majority of the time it looked pretty innocuous and it didn't have anything vulnerable in it. But if you went to that manage preferences link and you actually interacted with the widget, it started loading in more resources. And in particular, it loaded in a very vulnerable version of jQuery. And as a result of that, the customer couldn't find the vulnerable resource in all of their tooling. But when we looked at the world through the lens of all of their real users, and what are their real users coming in contact with, we were able to identify that the vulnerability still exists. And this is a door through which a successful attack could be launched tomorrow. So this comes back to just what are we trying to do? How do we make this big attack surface something that's manageable? Turning all these things off is not an option. So day in, day out, how do we get to request map-like visibility in every permutation of the user experience that's out there? Well, oh, and by the way, you still have to do everything else. So this is not a full-time job. This is something that you just have to fold into your operation cadence. You have to keep the velocity up. You can't have marketing change what they're doing. InfoSec isn't going to review every change, but we have this massive attack surface that is distributed across lots of parties that's changing all the time. So how do we deal with that? Well, we believe the way you do that is actually inspired by the way that you do performance management for real users. You want to look through the lens of the front end in all of your real user perspectives. So this is what we've done with Akamai's Page Integrity Manager. It looks at the world from the perspective of all of your real users. It instruments their browser to essentially say, what are all the scripts that are present? Where did they come from? Where do they compel the user to communicate to? And what are they doing when they execute? And from that, we pump it all into a detection cloud where we can say, okay, across all of those resources, which ones have known vulnerabilities? And that's where Snyk is a really exciting partner for us to get even more actionable, in-depth knowledge about how to fix the vulnerabilities that we find together. And we're looking at not just what are the assets and where did they come from and where did they communicate to, but what did they do when they ran? When they run, if they're going to do something suspicious or malicious, we'll be able to observe that actual behavior. It's easy to try and obfuscate code, to hide code and all of that, but as we all know from kind of the antivirus world, at some point code has to execute. And if you can understand the behavior at execution, you can find suspicious and malicious behavior regardless of what the code looked like or where it came from. And using those two things, we believe this is the way to stop front-end threats like MageCard and web skimming and still let web application teams go fast and use that rich ecosystem of tools and resources that are available to build these rich interactive experiences, but do so in a way that we can keep an eye on that big front-end attack surface day in, day out, across all permutations for all users. If you want to learn more, akamai.com/pageintegrity. And thanks for listening.